In this video we're going to find the perpendicular distance from a point to a line. So here's our line, 3x minus y minus 2 equals 0. Here's our point, there. And the perpendicular distance then is the distance from that line, from that point to the line, which makes a right angle with the line. Okay, it's basically the closest distance to the line from the point. How we do it is we have this formula. This formula is taken directly from our logbook, so we don't need to learn it. And we do know though how to, slot the numbers into it. So the distance from the point from the line is a x1 plus b y1 plus c over a squared plus b squared, the square root of that. Okay, so a is basically the number in front of the x, b is the number in front of the y, c is that number, and x and y, or x1 and y1, are the coordinates of the point. Okay, so with that in mind, generally what I'll do is just write out here what a is, what b is, what c is, what x1 is, and what y1 is. Just the way I won't make any mistakes. So a is 3, b is minus 1 because that's a minus, there's an invisible 1 there, c is minus 2, x1 is 1, and y1 is minus 4. And we just slot it into this then. So the distance equals the modulus of, well, a is 3 and x1 is 1. And then we say plus b is minus 1. So we have minus 1 there. And then y1 is minus 4. Plus c minus 2. And it's the modulus of that all over the square root of a, which is 3 squared, plus b, which is minus 1 squared. Could throw it all into the calculator. Now bear in mind that whatever number we get here, we have to take, whatever number we get on top, we have to take the positive version of it. So I'll just do it out. 3 multiplied by 1 is 3, minus 1 multiplied by minus 4 is plus 4, plus 4, and then we have our plus minus 2, which is minus 2. And that's all over the square root of 3 squared, which is 9, plus minus 1 squared, which is 1. Distance equals 3 plus 4 minus 2, which is 5, over the square root of 10. And if we type that into the calculator, we get the distance is 1.58, correct, 2 decimal places. So the distance from here to here is 1.58. Okay. Okay, next question. It says find the perpendicular distance between the parallel lines 3x minus 4y plus 12 and 3x minus 4y minus 1. So I've drawn the two lines there, and we're looking for the distance between the two lines, perpendicular distance between two lines. So if I choose, let's just say this point here, and get the perpendicular distance to that point, that's actually going to be the same distance from here to here, and from here to here. So basically, I can choose any point on one of the lines, get the perpendicular distance from that point to the other line, and that will work it out for me. Okay? Because if we look at this question, we're getting the perpendicular distance between two lines, whereas we have the formula to get the perpendicular distance from a particular point to a line. Therefore, what I must do is choose a point on this line and get the distance of that to that line. Okay, so How am I going to choose a point on this line? Well, I suppose the easiest way to do it would be let x equal 0. Okay, we let x equal 0, we find out what the y value is. Or let y equal 0 and find out what the x value is. Right? In this instance, I'm going to choose actually this line here to get the point on. You'll see why in a second. Okay. Now you could choose this line to get the point on, but I've just noticed something here. So I'm going to let x equal 0. That would be minus 4y plus minus 12. So y equals 3. So y equals 3 when x equals 0. So there's a point on the line. So I'm just going to put in that imaginary point. Say it's here. 0, 3. And now I have to get the distance from that point, the perpendicular distance from that point to that line. Okay. Now why did I choose this one rather than this one? The only reason I did is because I noticed here if I let x equal 0, I would get a whole number. Whereas over here, if I let x equal 0, watch what would happen. Minus 4y equals 1. So y equals minus a quarter. So the point would be 0 minus a quarter. And I didn't want to be dealing with fractions, okay, so I just chose the other one that would allow me to get a nice point. Okay, that's the only reason. So once I have my point, there it is, 0, 3. I have my line now, 3x minus 4y minus 4 equals 0. I get the distance from that point to that line using this formula. D equals the modulus of ax1 plus by1 plus c over square root of a squared plus b squared. What I do is I label out my a, my b, my c, my x1 and my y1. So a is 3, b is minus 4, c is minus 1, x1 is 0 and y1 is 3. I slot those into this. D equals modulus of a, so it's 3 multiplied by 0 plus minus 4 multiplied by 3 plus minus 1 all over a squared is 3 squared plus minus 4 squared. So D equals 3 zeros are 0, minus 4 multiplied by 3 is minus 12 minus 1 all over square root of 9 plus 16. D equals minus 12 minus 1 is minus 13, however we're getting the modulus of that, so it's positive 13 over square root of 25, which is 5. And that will give us D equals 2 and 3 over 5. Okay, you could write it as a decimal if you wanted. Okay, next question. It says find the equation of two lines which are parallel to the line 3x minus 4y plus 1 equals 0 and are 3 units from it. Okay, we're just going to sketch that out. So here's that line, 3x minus 4y plus 1 equals 0. Now two lines parallel to that and are 3 units from it. Well, that must mean the one line would be 3 units this side of it. So it would be here. It's 3 units that side. The other is going to be 3 units this side of it. Okay. Now, the way or the form that this line will take will be 3x minus 4y plus some number. Okay, so really what it is, it's the same as that if you notice the 3x minus 4y, but the fact it's to the left of it or to the right of it, instead of 1 here, so instead of that being a 1, it's going to be some other number. Right? So parallel lines have the same x number and the same y number. Likewise for this line here, that's going to be also in the form 3x minus 4y plus k equals 0. So it'll be another number. Okay? It'll actually be minus k equals 0. So whatever number this is, for this line, it'll just be minus that number for this line. Okay? So how do we go about this? Right. Okay, so here's what I do. I get a point on this line, find a point on that line, so let's say it's here, and I find the distance from here to here. Sorry, I don't find the distance, I know the distance is 3. Okay, that's the, I suppose, the basis of how I'm going to find this. So watch. I'll find a point on this line. Let's do that. 3x minus 4y plus 1 equals 0. I'm going to let x equal 0. So 3 zeros minus 4y plus 1 equals 0. So minus 4y equals minus 1. So 4y equals 1. So y equals a quarter. So the point is 0, 1/4. Now, so there's my point, 0, 1/4. It's on that line. I know that this line here has the 3x and the 4y, and I'm just looking for the k. I also know that it's a distance of 3 units away from that. Okay, so here's what I do. Write out my formula. It will be a x1 plus b y1 plus c all over a squared plus b squared. And that will find me the distance between the point and the line, but I already have that. It's 3. Now, it's plus 3 on this side of the line. It's minus 3 on this side of the line. Okay, so if we're asked any questions like this, just remember, say this is plus 3, and this is minus 3. Right, and now I fill in what I know. So again, I'll write out my A, B, C, x1, y1. So A is 3, B is minus 4, C, I don't know, it's K, that's what I'm looking for. Okay, I'm looking for this. x1, 0, y1 is a quarter. We fill in what we know. So 3 multiplied by 0 plus minus 4 multiplied by a quarter plus c, which I don't know what it is, we call it k, all over square root of 3 squared plus minus 4 squared. That will equal plus or minus 3. 3 zeros are 0, plus minus 4 multiplied by a quarter is minus 1 plus the k, all over the square root of 3 squared is 9, 4 squared, so 25. That again will equal plus or minus 3. So nearly there. Modulus of minus 1 plus k all over 5 equals plus or minus 3. So we know what that formula equals. It equals 3, which is the distance from the point to the line. Okay, I'm going to label out my A, B, C, x1, y1. So my A is 3, my B is minus 4, my C is k, I don't know what it is, my x1 is 0, my y1 is a quarter. I fill it into this formula. 3, 0 plus minus 4 quarter plus k all over root 3 squared plus minus 4 squared, and that all equals 3. I simplify it out. 3 zeros are 0. Minus 4 multiplied by quarter is minus 1 plus k. That's all over. 3 squared is 9 plus 4 squared is 16, so that's 25. So the square root of 25 is 5. And that equals 3. Now notice here we have the modulus, which means this here is always going to be plus. And you should know from algebra how we solve that is we get rid of it. However, once we get rid of it, we look to the other side and we say that's plus or minus. Okay? The other way of dealing with this modulus sign, okay, was if we squared both sides. Okay? But remember, if we squared this here, we'd end up getting a messy enough sum. Okay, so the easiest way to do it is get rid of the modulus bars and then say plus or minus on the other side. Right, I'm going to do two sums then. We have minus 1 plus k over 5 equals plus 3. And then over here I have minus 1 plus k over 5 minus 3. Okay, to take account of the plus and the minus. And that would be k multiplied by 5 on both sides. We get minus 1 plus k equals 15. So k equals plus 1 for both sides, 16. And over here then we have minus 1 plus k, and we multiply by 5 on both sides, and we get minus 15 plus 1 to both sides. We get k equals minus 14. Okay, so go back to our question again. Find the equation of two lines which are parallel to the line 3x minus 4y plus 1. So 3x minus 4y plus 1, that was the original line. And remember we said the other two lines then are going to also be 3k minus 4y plus, and we were looking for the k, and in one of those lines the k is 16, and in the other one of those lines the k is minus 14. So there is the two parallel lines to that, which are also a distance of 2 units either side of it. Okay, the last type of question you could be asked with this is investigate if the points, 2 points, lie on the same side of the line, whatever. So in this case, investigate if the points 5 minus 2 and 3 minus 3 lie on the same side of the line 5x minus 4y minus 30 equals 0. What that means is, if I have a line here and I have a point and I have another point, those 2 points are on the same side of the line. However, if that point is over here, then those 2 points are on opposite sides of the line. Here's what I do. I check and see the distance of this point to this line, and then I check and see the distance of this point to this line. If both answers are positive or both answers are negative, well then they're on the same sides of the line. If, however, one answer is positive and one is negative, then they're on opposite sides of the line. In this question, notice here, if we're asked a question like this, where they're asking if points are on the same or opposite sides of the line, we do not use the modulus bars in the formula. Remember, the modulus bars are to give us always a positive answer, because the distance from a point to a line would always be positive. Okay? It's a distance, we can't get a negative distance. However, in this instance, for this question, do not use those modulus bars, okay? Because we just want answers positive or negative. Right, let's go. So first of all, I'm going to get the distance from point 5 minus 2 to 5x minus 4y minus 30 equals 0. Right, so my A, B, C, x1, y1 are as follows. 5 minus 4 minus 30, 5 minus 2. My formula, ax1 plus by1 plus c all over square root of a squared plus b squared. The distance is that. I do not use these modulus bars, not for these type of questions. Right, let's go. So the distance equals a, so 5 multiplied by 5 plus minus 4 multiplied by minus 2 plus c, which is minus 30. And that's all over the square root of 5 squared plus minus 4 squared. That will give me 25 plus 8 minus 30 all over the square root of 25 plus 16, and that will give me 3 over the square root of 42. Now I could type that into the calculator and get I suppose an answer not in solid form, but I don't really care about the answer. I just need to know that that is a positive answer. Now if the other answer is positive, I can say they're on the same side, same side of the line. However, if the other answer is negative, then I'd be saying they're on opposite sides of the line. Right, so the next one is the point 3 minus 3. So 3 minus 3, there's the point. The line is again 5x minus 4y minus 30 equals 0. We do it out. A, B, C, x1, y1. So it's 5 minus 4 minus 30, 3 minus 3. Okay, our formula then, we have it up here, so I'm not going to write it again. So we have D equals 5 multiplied by 3 plus minus 4 multiplied by minus 3 plus minus 30. That's all over the square root of 5 squared plus minus 4 squared. We know down here is the square root of 41. Up here then, 5 multiplied by 3, 15, plus 12 minus 30. We get d equals minus 3 over root 41. And that is a negative answer. So if we look up here, if the perpendiculars on the same side of the line have the same signs, perpendiculars on opposite sides of the line have opposite signs. Okay, simple answer for that is if these are different, then they are not on the same sides of the line. So the question is, investigate if points 5 minus 2 and 3 minus 3 lie on the same side of the line. We can say 5 minus 2 and 3 minus 3 do not lie on the same side of the line. What was the line? 5x minus 4y minus 30 equals 0. So what it means is one point lies on this side, the other lies on the other side. Okay, thank you.